Now let's look at the role of HT1 in the regulation of stomatal opening in response to blue light. Remember from the earlier video and from your reading that HT1 is changing stomatal aperture as a function of the environmental carbon dioxide levels. What's this graph tell us on stomatal conductance as a function of blue light radiation? So blue light is not present at the beginning of this experiment, and that's this dark part of the bar. Blue light exposure begins at this moment and is maintained throughout the rest of the experiment. When blue light is shown upon the plants, you'll notice that the wild type plants have stomatal opening. How do we know they have stomatal opening? Well, in this case, they chose to measure how much water vapor was leaving the stomata. Notice, in one place in the paper, they measured the temperature of leaves to tell us about stomatal opening. In a second, they measured physically, using a microscope, the physical opening, the aperture. And in this case, you're measuring how much water is getting through. But in all three cases, you're measuring essentially the same thing. Okay, so wild type plants have their stomata open when they're exposed to blue light. What about HT1-2? I erased the HT1-1. It was ambiguous and it's in the middle here. But HT1-2 mutant plants, they lack HT1-2 function. And yet, you'll notice that there is a response to blue light. You'll notice that that response to blue light is not as strong as in wild type, but nonetheless it exists. So what do the authors take this to mean? Well, their hypothesis is as follows. That is that HT1 is involved in blue light opening of stomata. However, even in the absence, and remember the way you open stomata is to get that pump going. However, in the absence of HT1, you still see some increase in stomatal opening. And so blue light must have a second pathway through which it also works to increase stomatal opening.